Okay, so on this one, this is on angles and the coordinate plane. Okay, angles in the coordinate plane. First, in geometry they defined an angle as two rays connected together at a vertex point. The difference in trig, now they're still got the ending is still going to look the same, but the difference in trig is they're going to take a initial ray. Okay, everybody look up here for a minute. They're going to take an initial ray and then they're going to rotate it. Okay, it's still going to look like this when it gets done, but they're basically starting with an initial ray and then end up with what they call a terminal ray. So they will take this ray and rotate it. Still looks like an angle. Okay, so this one has a special name. It's called the initial ray, and where it stops, that is the terminal ray. Okay, and where it's connected together, that point is the vertex. Okay, so definition-wise, an angle is formed by the rotation of a ray about the vertex. Okay. The other difference in geometry, everything that you did in geometry with angles was positive. Okay, it was a positive 30 degrees, a positive 45 degrees. Okay, and when we're doing angles, if you rotate that initial ray up, you're going to end up with a positive angle. Okay. If you go up, it's positive, and that's also going counterclockwise. You're going against the clock. Okay, so counterclockwise, if you're going up, it's positive. If you take your initial ray and rotate it down, okay, then you're going to end up with a negative angle. So if you rotate it with the clock, you know, and that's one of my concerns down the road when we go totally digital. You know, some of the new elementary schools have actually removed all their digital clocks and have gone back to the old time clocks like we have here. Okay. Okay. When we look at angles, we're going to look in the coordinate plane, and we talked about this yesterday, but each one of these quadrants, okay, the coordinate plane separated into 4 quadrants. The upper right hand quadrant is quadrant 1, quadrant 2, quadrant 3, and this one is quadrant 4, and it's I, V. Okay, and those are the 4 quadrants. You basically have to have those memorized. Okay. Now there is a key phrase when you're going through the homework, and it's called the standard position of an angle. And they talk about this basically so we all agree where we're starting. Where is that initial ray starting out? Standard position of an angle. Okay. In a coordinate plane, when the vertex is at the origin, so they're saying that you're starting the vertex at the origin, okay, and the initial side is on the positive side of the x-axis. So when you see this phrase, standard position of an angle, it's telling you where you're starting. You're starting with the vertex at the origin, okay, and we're starting right here on the positive, your initial side starting right there, okay? That way we all know where we're starting, okay? It's on the positive side of the x-axis, okay? And I'll get to some of that in a minute, okay? The next thing the author defines is a quadrantal angle. Try saying that, quadrantal. Quadrantal, okay? A quadrantal angle. Those are angles in standard position. So that tells you where the initial side is. It tells you it's starting at the vertex, at the origin. Okay, it's angles in standard position whose terminal sides coincide with either the x or y axis. A quadrantal angle, okay, it's in standard position, so it's got to start on the positive side of the x-axis, and the terminal side coincides with either the x or y axis. So draw a couple sketches here. Here's an example. Okay, if we start here, okay, and I can rotate this up, my terminal side is there. So that would end up to be a positive 90 degrees. Okay. If I start on the positive side of the x-axis, I have to end on either the x or y axis. So if I rotate positive, okay, I go up, so that'd be 180 degrees. Okay. If I start here on the, let's start here on the positive side and go down here, that'd be a negative 90 degrees. Okay. You can rotate, say I start on the positive side, and let's say I go all the way around to here. Okay, and I'm going up, so that'd be a positive 270 degrees. So, quadrantal angles are multiples of what? 90. They have to be multiples of 90. They can be positive, they can be negative, but they have to be multiples of 90. Okay? Okay? In geometry, you probably labeled all the angles with letters, like A, B, C, D, E, F, like labels. Okay, but in Trig, most of the angles are labeled with Greek letters. Okay, so they will use letters. Everybody look up here for a minute. This one is the Greek letter theta. Okay, so okay, you've already used some of the Greek letters like sigma. We did that, the summation. Okay, look on page 16 in your book for a minute. The Greek alphabet is there in a box. Page 16, where it says extra. Okay. Okay, now that has both the uppercase letters. Look at sigma, for example. We did the uppercase sigma in pre-calc, okay, and we did the lowercase sigma. Okay. Now for Trig, these are probably the main ones that you will see in the beginning. Okay. This theta. Everybody look up here for a minute. This one. Okay. This one is alpha. Look at how that's made. Start here. Start at the top and go down. That's the easiest way. Looks like a little fish, but don't call it fish. It's alpha. Okay. The Greek letter beta. Okay, look up here for a minute. Okay, beta starts at the bottom and goes up. Okay, that's beta. Spell it right. And the easiest way to make that, you start at the bottom. Okay, beta. Okay, and another one that we will use is omega. Looks like a W. Don't call it W. It's omega. Okay. Another one that you've already used in math. You've probably used it for the empty set, and that's the Greek letter phi. Okay. Another one that we will use is delta. Okay. So if there's one that you're not sure about the letter, how to say it, what's the letter look like, it's on page 16 in your book. Okay. Okay, the next thing the author defines is coterminal angles. Okay, coterminal. Okay, coterminal angles are angles in standard position. You'll see that phrase a bunch. That tells you where it's starting. It's on the positive side of the x-axis, and the origin is the vertex. Okay, angles in standard position whose terminal sides coincide. Okay. Okay, let's look at an example. If you let theta equal 30 degrees, find the measure of a coterminal. Let theta equal 30 degrees. Find the measure of a coterminal angle with two rotations counterclockwise. Okay, now you can do this by picture. You can also do it by formula. I'm going to show you both ways. Okay. First, draw a sketch. And Trig's just like pre-calc. A sketch is going to help a bunch. In geometry, you almost always want to draw a sketch. Okay. Okay. So on this one, first draw your theta 30 degrees. So we're going to start here on the positive side of the x-axis, go up about 30 degrees. Okay, and label that. All right. Now they want the angle that is coterminal with that, two rotations counterclockwise. Okay, so you're going to start on the positive side of the x-axis, two rotations counterclockwise. So you got to go, here's one. What's one rotation counterclockwise? 360, right? So 360. Go around again would be how much? 720. Now the terminal sides have to coincide, so you got to go up to meet that terminal side. So 720 plus 30, 750 degrees. Okay, so you can do it by picture, or you can do it by formula. Here's the formula: n times 360 plus theta. Okay, that's the main formula for figuring your coterminal. Okay, n stands for the number of rotations. If you're going counterclockwise, if you're going positive, if you're going up, it's positive. So on this one, we would sub in, we went two rotations, okay, times 360 degrees, plus our theta was given to us, 30 degrees, order of operations, 720 plus 30, 750. Okay, should get the same answer whether you do it by picture or whether you do it by formula. If you go clockwise, then this n becomes negative. Okay. Okay. Let's do one of those. Okay. Same directions. Change the angle. Let's say the angle theta that they give you is 45 degrees. And let's go one rotation. On this one, let's go one rotation clockwise. Okay. Now, picture-wise, this one ends up to be a little bit different on the picture. Okay, so let's go 45 degrees. So just draw a little sketch. Start here in standard position. Go up 45 degrees. So split that quadrant 1. Okay, and there's our 45 degree angle. Okay, now go one rotation clockwise. Now, the difference on this is that you don't go all the way around. Okay, you're going to start in standard position. So you're going to start here. Clockwise, you're going down, and then you go until you meet that terminal side. Okay, so now you got to figure out what's this angle. Okay, so what's 360 minus 45 would be what? 315, but you're going in the negative direction, you're going down, so it ends up to be a negative 315 degrees. Okay? Or you could have done it this way too. You could have done negative 360 plus 45 and get a negative 315. You could write it like that too. Okay, now let's do it by the formula. N times 360 plus theta. Our N, since we're going down, it's a negative 1 times 360 plus 45. Yep. So you get the same answer whether you do it by the picture, okay, or whether you do it by the formula. Should end up with 315 degrees. Okay. Any questions on that one? Okay. One thing they will ask. They will ask you to draw a sketch, sketch an angle, and find its measure. Okay, and let's say they give you 3/4 of a rotation clockwise. Okay, 3/4 of a rotation clockwise. Sketch the angle. Okay, so just sketch, and we're still in standard position. 3/4 of an angle clockwise. So start in standard position. Luckily, our coordinate planes is divided into fourths. So clockwise going down. So here's 1/4, 2/4, 3/4. Okay. Okay, so it'd be a negative 270. Yep. Okay. Now, if you do that by, you can do it by the sketch and find the measure. You can also do it 3/4. What's one rotation clockwise? If you're going down all the way around, what's all the way around? 360, and we're going down, so it'd be times a negative 360. And that's like 360 over 1. Okay, and you can reduce this. 4 goes in there once. 4 would go in there a negative 90. Then multiply across on top. Multiply across on the bottom. Okay, so you can do it algebraically. You can do it by the sketch. Okay. Any questions on that? If you're going counterclockwise, it's positive 360. Okay, clockwise, it's a negative 360 for a full rotation. Okay. Okay.